Okay, cool. So let's go through. In skeletal muscle, the thin contractile protein filament containing active or binding sites is known as what, Tash?
Actin.
Yeah.
But I cannot take credit for that. So you help me.
What is attaching to actin? Myosin, yes. What is the currency that is used that makes myelin, myosin clock back? Say that again?
AHT.
So close. ATP, adenosine triphosphate. But yeah, good work. ATP is needed. So remember that is your body's currency for energy. ATP, adenosine triphosphate, and plenty of other things are needed as well. Calcium, for example, for muscle contraction.
Do you think we might need to have that new term?
Know that term.
Oh,
Just
God.
recognise
Can you just say it
ATP.
ATP.
Adenosine triphosphate. Question 2, would you get Serena? What is the function of the arches of the feet? Yep, supports the body, supports in gait, your walk. How many vertebrae in each part of the spine? Linda, what have you got?
I've got C7,
Yeah,
T12,
yeah,
L5,
yes.
sacrum 5, coccyx 3 to 5.
Yes! This makes me
Yay!
so happy. Did everyone get that? So the sacrum and the coccyx are fused. There's no articulation or mobility within that. Yeah. What is voluntary muscle also known as, Maxine? Skeletal. Correct. Yes. Charlie, what do ribosomes do?
Doesn't it like produce something?
Yeah.
I can't remember.
It manufactures. Anyone? Proteins, yes, manufactures proteins. What you know is a function of a ligament? Bone to bone. What is the term that attaches muscle to bone? Tendons, yeah. Where is non-keratinized epithelium found, Tash? Yes, wet surfaces inside the mouth. What does keratinized mean? Dead. So non-keratinized means alive, non-dead. Yeah. Imagine if we just called ourselves that. We're all non-dead. What is another name for a stem cell? Ada, what did you get?
Can't remember. We covered last week now.
Mes. Anyone?
Mesenchymal.
Mesenchymal,
Oh.
yes.
First of all, I wrote neuron, and I was like, I know that's not right, but I couldn't think. And then I remembered and wrote mesenchymal.
What is a mesenchymal stem cell?
You said, you told me last week.
It's something that all connective tissue cells have in common. Connective tissue is such a broad tissue category, and mesenchymal stem cell is what all connective tissues start at. So it can choose if it wants to be bone, blood, fibre, cartilage, anything like that. So mesenchymal stem cells is what the one thing that all connective tissues have in common. They obviously all connect, but if you're looking at something like how is bone in the same category as blood and cartilage, like it can be really off-putting, but actually when you look at a cellular level, they all start from that foundation. So mesenchymal stem cell. What quadrant of the body is the gallbladder? What did you get for this one?
Right, lower.
Right is correct, but it's upper right quadrant. It's upper right quadrant. What is an agonist? Does anyone get? Huh? It's the opposite of an antagonist. Think of low.
It's a muscle that moves.
So it's the primary mover.
Primary, yeah, that's it.
It's the one. It's a muscle that contracts to cause movement, and the antagonist is the opposite of that. Remember, your exam is going to be multiple choice, so your answers are going to be there. Sometimes that can throw you off even more if you've got a few options, which is why I recommend if you're doing any revision, have open questions. You know it in your head, and then the other questions can't throw you off. So that is your answers. So if you've got a few of those wrong, have a go for homework with doing them again. So we're looking at the nervous system today. What is a neuron? Anyone?
A nerve cell.
A nerve cell, yes. A neuron is a nerve cell. This is the description from the VTCT website. So neurons or nerve cells are part of the nervous system and transmit information between different parts of the body. The neuron has an important role in the production of neurotransmitters. We're going to be going through neurotransmitters, and these carry specific signals. So the majority of neurons are composed of several main features: a cell body, dendrites, and an axon. So we'll go through that in detail. And the cell body contains a nucleus and other structures that are commonly found in living cells. It supports the chemical processes of the neuron. Dendrites, these are what we call as like the listeners. So the dendrites are generally thin structures that become narrower as they branch away from the cell body. They extend from the cell body and overlap between other neurons and allow communication at the synapses. They can receive incoming information. The short outgrowths of the dendrite create a wider receptive surface area of the neuron. I would like you to read this at the end of the session or tomorrow, have another look through it, because at the moment it can seem quite wordy. Now we're going to break it down after, and I'm sure if you were to reread these paragraphs again, it will make more sense. So the axon of a neuron is a singular fibre that carries information away, and it tends to be much thicker and longer than the dendrites. The myelin sheath covering the neuron is composed of fats containing cells which insulates the axon from electrical activity and speeds up the nerve impulses passing along it. There are regular gaps along the myelin sheath called nodes of Ranvier, which actually help to boost the nerve impulses as they pass along the axons. Neurons are irreplaceable. That's a good fact for you there. And yeah, neurons are some of the longest lived cells in your body. We spoke about erythrocytes. What's an erythrocyte? What is erythema in the massage? Redness.
Oh, yeah.
So red. So what does cyte mean? Cell. So an erythrocyte is a red blood cell. Yeah. So red blood cells, they don't last long at all, and they're constantly being repaired and broken down, whereas neurons are not that replaceable. Okay, so looking at the bigger picture, and then we're going to zoom up and I'll give you some visuals of axons. So you've got sensory neurons, afferent neurons, and these transmit impulses from sensory receptors towards the central nervous system. So when you're looking at the body, afferent give the messages to the brain. So these are all the different types of receptors that can sense the information. But I always think of an afferent. So what's the opposite to afferent? Efferent. Yeah. So afferent, I always think of A for this A-star student. And A-star students will always run and tell the teacher. They'll be the ones that will like dob you in and tell tales and bring this teacher an apple, that like classic image. So A-star students are always going to the teacher, and then you've got E students are like, I'm leaving school, I'm not coming in, I'm going out, I'm going away, and you're always referring to the brain. So afferent always going to the brain, think of like that as school or teacher, and E students are like, I'm bunking up, I'm going away, I'm not interested. So A and efferent. So afferent are go to the brain, and efferent go away. So they're your sensory neurons. And the reason, if you actually think sensory, like they touch and feel. So the way it works is whatever you're coming in contact with, that whether that's light or taste or touch, you have senses coming in. Your brain actually has no access to the outside world. It's just in a black room of your skull, rattling around, and it never gets to see the light of day or anything. So your receptors give your brain the information. That's how it works. You have sensory input. So if I touch something, I've got mechanoreceptors that are saying this is soft, this is okay, this is an average temperature. That information is going to my head, and their integration is where that information is processed. You then have outgoing information that says do something about it. So, for example, I put my hand on a hot stove. That information goes up to my head. My brain processes and is like, do something about it. Get your hand off the stove. So then I have efferent students going away from the brain that goes out, say, move, move, move. Lift your hand up. So that's what motor neurons do. So the sensory neurons, all they do is bring information in. Motor neurons do something about it. So sensory information is the afferent, motor is the efferent. Happy with those two? I've just listed here some of the receptors that you will have. So thermo will respond to changes in temperature. Photo receptors obviously respond to light. Chemoreceptors pay attention to chemicals. Mechanoreceptors respond to pressure, touch and vibrations. And nociceptors, these are receptors of pain. Mechanoreceptors we spoke about before. We were talking about how they're in the skin. So you remember we were saying like if you're on a tube and you're like leaning next to someone and you've got that pressure, you feel someone's arm next to your arm. That's one type of mechanoreceptor. And then you've also got like when you put your clothes on, you can feel your clothes against your skin, and eventually that begins to dull down. So all day your brain isn't being told, I've got something touching my skin, I've got something touching my skin. That chills out. So you've got all these different types. Ruffini receptors is an example of a mechanoreceptor, and that detects vibration. So it's all these different ones. For me, it was actually when I used to live in New Zealand. I was living in Wellington, and it's on a fault line, and so you're constantly feeling vibrations from earthquakes. And so actually, whatever job you have, you not only have like fire training, go to this place, you have to have your in the middle of an earthquake training, like how to get to the table, what pillars are safe, where not. Like it's really scary. But for about 2 years after, because we were in a really scary one actually, and I just froze. I was not very good at responding. But for about 2 years, if I was in a supermarket, I remember being in a supermarket with my mum and being stood next to the escalator and the vibrations of the escalator, and I just like went into full panic mode, and I was like, Mum, get down! But so that's Ruffini that senses vibrations. So mine were like heightened at that point. But so you have ones that do all different things with regards to mechanoreceptors. The correct term for pain is nociception. So nociceptors sense pain. Have you been reading that book about the body? Yeah. Have you read about?
No.
When you get to there's a chapter, we were discussing how there's a really good book by Bill Bryson called The Body, and it's in like all the Waterstones charts at the moment. Amazing, fascinating book. That's more it's more logical, isn't it? And it's a bit more like lets you understand it in real terms. Very interesting. And there's a whole chapter on pain and about how that it's so hard to define. We actually all have the same pain threshold because it actually is a line of action potential, and we'll go into it in detail, but it's just like our limitations are different. So our threshold is the same, and everyone's like, my pain threshold is higher than yours. Well, it's not. It's just the way that you handle it is different. You'll all sense it the same. So yeah, it's a really good book anyway. So basically, sensory neurons and motor neurons, in and out neurons, and then these are the exact examples of receptors. You don't need to know these exactly, but that they're not going to be on your exam. You won't be tested on them, but I just think it makes sense to understand how that works. I do want to do a little example about how this information will work. So, Charlie, you're going to be the brain. You're going to process information. So, Serena and Tash, I am going to close this off and close this off. So the way it's going to work is I'm going to give Serena a challenge. So you say you want to walk over a step, right? What I explain. Imagine you're trying to walk. You've got a mission, and you want to get from this bed, and you want to get to where my bed is. I want you to pick up my water bottle. So you have to say, and you have got to try to get back to the brain. How are you going to do that? I am going to put an obstacle in the way. So Serena is the sensory neuron. She's then going to Chinese whisper to Maxine. This is how neurons work. One neuron passes information to the next. She's going to pass information to Maxine. Maxine is going to whisper that to Linda. Linda's going to tell that to Charlie. So all that you're going to do is you're going to say what's in the way. You don't have any say on how it works. You're just going to say, this is in the way here. This is how many steps. Whatever. Because that information will be to Charlie. Charlie's then going to say, okay, this is what I want you to do about it. I want you to skip there or hop there. I want you to work out a way. Maybe you're going to take a big leap. Once you made that decision, Charlie, you then need to whisper it to Una. Una's going to have to whisper it to Ada. Ada's going to whisper it to you. And you're going to be blindfolded. And then you're going to stand in this spot. And you are going to be the one to pick this up. So I'm going to close off.
I just listened to Serena.
Serena's going to speak to you.
Can you put a blindfold on?
This
This is the mission to pick this up.
I've got to remember what they say to me now, though.
Yeah.
That could be a job.
You're going to hear it last, Tash.
Yeah, no. Well, yeah. That's still doesn't mean I'll remember.
Okay, so I want you to pick the water bottle up. Can you close your eyes? Yeah, put your blindfold on. Right, I'm going to move. So Tash is going to start where she is. You need to work out. Like, you just need to tell her what's in the way. Like, how many. How she's going to get there. Yeah.
So do we do it like
You just have time. You just work out. So if that was me, imagine I'm going here. Imagine this is when Tash is trying to tap. I probably say you need. Yeah. So, but I want you to get Tash to pick up my water bottle. Yeah. And now work it out. Now whisper it to Linda. To Linda.
No, you're going to tell me, and then I've got to listen.
And I've just got to say exactly the same thing. Okay.
Oh shit.
Oh my god.
Oh no.
Sounds like it's going to be hard.
Oh no.
Oh my god.
Oh,
Okay.
God knows what's going to happen. Oh God. Oh God.
Oh, sugar.
Yeah, that sounds about right.
Does it? That's pretty bleeding amazing. And then, oh crikey, I can't remember what she said last.
Oh my gosh, I'm not
Hang
going
on,
to
hang on.
You have to repeat.
I can't. Oh, I forgot the last bit. Hang on. I can't remember what she said. Oh no.
What's going to happen?
I can't remember.
Oh, no.
Oh, hilarious. Could I have written notes? That sounded very quick.
You need to tell Una. Just whisper, yeah. So now,
You've got to repeat what Linda just said. Something like this, something like this. I can't remember if Serena even said that or not.
so Charlie's obviously saying, I don't know, because she can't see it. She's relying on you guys.
Oh, yeah.
Yeah.
It's not like it's talking.
That's about short-term, long-term memory, like if you saw it, because there are the memory competitions, aren't there? That they have, like in America, they like memorise.
See, I'm
ages.
not that good at that.
Directions.
Yeah. I think I might add something.
Yes, I think there might
I
be
know what
something
I
on the
said.
end.
I know what I said, but I don't know what I was told.
I don't know if you said it or Chloe earlier, but it was
Yeah.
in my brain.
Oh,
Did you say
Okay, so you need to tell Tash. Right, here we go, Tash. This
Can
is
I
your
say
moment.
now?
Tash.
Should I say now?
Just whisper it to Tash.
Just get killed. That's hilarious.
Let's go, Tash. That instructing is very good. That's it. That's it. So, let's go.
Oh, God, I feel like
Yeah. Now you're missing. So now you need to go again. So just from this position, you need to go and quickly tell Maxine, let's go quick. Tash has got to get our bottle.
And then I've got to quickly tell, oh, hell yeah.
Yeah.
What I got was a Liverpool jump. I don't know where.
I know, I'd have had her in the screen.
Quick.
Oh, shit.
It actually took this long to do it. I'll be there in a minute.
What type of neuron are you? You're going, Charlie's the brain.
I'm not very good.
I'm not emotional.
What type of neuron are you?
I think I might be ruining it. I'm an afferent
Yes.
neuron.
Yes, you're sensory.
Yeah.
You're the ones with the information,
Yeah.
so you can see it.
And then,
So what is Ada?
she's the same.
No. What type of
Oh.
neuron are you? Motor. She's the one. It's gone to Charlie.
Yeah.
Now we're going away from Charlie.
Oh,
Now we're trying to
crikey.
tell the information.
Oh. See,
Tash is a motor neuron. She can't see.
Oh, yeah.
The information's meant to be coming from you guys.
Oh, hell yeah. I don't really know. I think I make things up.
That's not helpful in this situation.
I've got issues.
Okay.
Chinese whisper
Right.
did work.
Okay.
Oh shit!
Yes! Now what?
Turn right.
Oh no, the water
Turn
bottle
right.
moved.
We got there. We got there in the end. Well done. Yeah. So
I thought the water bottle was over there.
That was really horrible, actually.
No,
I
no,
just made it up. I just
Guys-
I was like 2 steps back, 2 steps back.
So these guys, Tash, Una, and Ada were motor neurons, yeah? They were the movers. They were telling Tash what to do.
Yeah.
You guys were relaying the information. You saw what happens,
Yeah.
and then it goes to Charlie. Charlie's the brain.
Oh yeah, forgot that bit.
Efferent now is going away from the brain, and this is what it does. So really, the way it works is basically Serena. If Serena was to take a photo of that situation, she could have. Another way we could have done it is that she passed the photo to you. You passed the photo to Linda. Linda passed it to Charlie. Charlie now says, "Oh God, okay, take 2 steps forward, 2 steps back." Then Charlie keeps hold of the photo, but she just tells Una, tells Ada, tells Tash, and then Tash knows what to do. So you're bringing in the sense, you're bringing in the information, whether that's light or touch or pain. Charlie's doing something about it in the brain.
Yeah.
Now you guys are actually passing information until you get to the final muscle. Tash would have been the final muscle. Serena would have been Serena would have been a photoreceptor because you're seeing, you're trying to work out. So Serena's a photoreceptor, you guys are a sensory neuron, Linda's a sensory neuron, then it goes to the brain. Now it's going through efferent, motor neuron, all the way down to the muscle, which finally moves. So that's the way it works. You can do it with a number of ways. I was lying in bed last night thinking I should have done with you guys, you know, the box, the cardboard box where you feel.
Oh my gosh, yeah.
Maybe we'll just do that for revision, just for.
Doing that, aren't they, on Celebrity?
Oh, we could have done our own version. Are we happy, yeah, with sensory neurons and motor neurons?
I think I broke the
Process. I'm happy with the process, just.
Funny that was.
Okay, so this is the image of a neuron.
I never was good at marketing. That's what I work from home.
So basically with the neuron, the main part is called what? Cell body, and the nucleus is within that. From here you have the listeners, which are called dendrites. Yeah. So from here, this is the long tail. These are the listeners. So you've got the dendrites, which are the ones that are like creeping out here from the cell body. They are the listeners. I always think of the dendrites as the nosy neighbours. My mother-in-law will sit outside her window and be like, they've got an extra car on their drive.
Oh,
Who's going in there? I'm like, oh my god, get away from the window. It doesn't matter what's happening. Like, I'll probably go out on YouTube actually. Better provide the link from that. But yeah, always wanting information, like gossiping, just trying to work out what's going on. These are the dendrites. They're clinging for information, like desperate for someone to tell them something. This information then goes into the cell body. It then travels down the axon, which is the tail, and comes all the way down to the synaptic cleft, to the synaptic knob, the synaptic bulb here. And I'm going to talk through what a synapse is. With that, so that looks quite simple, right? We've got the nucleus, the cell body. Just generally, is the cell body is the main bulk of it. The dendrites are the gossipers. And the axon is how it travels down. It then comes through to the synaptic bulb, which is where you've got the next cell. This is another cell body. And the dendrites are there. The listeners are there waiting for the next information. So the synaptic bulb is where the information crosses. So what you have is the dendrites looking out of the window, looking for information, looking for gossip. Oh my god, I've just seen him go in that house. Right, now that information has come in. It comes into the house, into the main bulk of the body, and then it's spoken to the next neighbour. She goes into her house, goes into the garden, leans over the fence, and neighbour B, the next door neighbour, has got her ears open, listening to that information. She then takes that information, she goes back into her house, processes the information, goes into her back garden, leans over her fence, the next person is there waiting to listen, and that's basically how we did it through Chinese whispers. And you didn't physically take the information from Serena or Linda, you didn't take it from Maxine. It was whispered. There was a space between you, and that's what a synapse is. So I'm going to go into detail. Actually, before I do, you can just see here, in that opening paragraph we had, it spoke about a myelin sheath. This is this fatty, they look like sausages really, so you can think of it like that. These insulation called the myelin sheath. And you have these little spaces in between that are called the nodes of Ranvier. And what the nodes of Ranvier does is it enables the information to jump and to quicken. So you have the information, the listeners bring the information in, it comes into the cell body, it wants to travel down and tell the next cell, the next neuron. So instead of having to go all the way down the axon, it just jumps next space, next space, next space. Instead of having to go all the way down, it just jumps in between. You have this electrical current. Does that make sense? Why you have the insulation, just so you've got the gaps and it can jump between. I'm going to go into that in a bit more detail with regards to the electrical current. So, these are the synaptic bulbs, right? That's where the information is going to travel. You've got the next neuron is here, and the dendrites are ready. This space here, in between, is where the information is going to travel past the synaptic cleft. But first, that information has come from the cell body and travelled down the tail. What's the tail called? Axon. So you've got the cell body, dendrites are the listeners, axon is the tail. So the axon extends from the cell body, is a nerve fibre that is the longest process in the neuron. What happens between cells is you have an action potential. So electrical signals that travel from one neuron to the next until they reach the target organ. So ours is a muscle, for example, and we were trying to get that information back. So you can see here you've got one nerve cell, one neuron. Then you're going to have that information. So you're coming from, so that's the end of a neuron. The information has travelled into the dendrites, the listeners, into the cell body, comes down the tail, jumps through that insulation, through the nose and around the air. That listener of the next cell is then ready to take it. That information comes through down the axon, and it just keeps going. The way that it does this, and the way that it travels down the axon, is through an action potential. It's about electrical currents. You have it generally on the outside of a cell, it's more positive. Generally on the inside of a cell, it's more negative. The body likes balance. So what happens is when an action potential is a force that comes in that's strong enough to do something. So it's when you actually, if someone, like a little tiny minuscule fly was on me, you know when you see those little tiny dot-like insects, they're so light, you could see it and then be like, oh, it's only because you've seen it you want to flick it off, but you might not have felt it, because the action potential, the strength, was not enough to actually cause you any action. It was only when you saw it you wanted to flick it off, but you didn't feel it. So therefore, that action potential wasn't strong enough to create any movement. But generally, if someone were to slap you, you'd be like, oh God, that is strong enough, that's an action potential. Therefore, so this is how we have the information travelling. The information comes in. You have sodium and potassium, which are the big players in this game. That what happens is, you've got the electrical currents, the sodium and potassium, they open a little gate in the neuron. You've now got more positively charged atoms running in. So now we've got more positive coming into the axon. What you want to do, the body is trying to create balance. So then it throws out some negative ones, because it's trying to get everything back to a neutral position. And then now, this charge is travelling. Because it's going to travel down, by the time it's pushed the negative and positive atoms out from down below, this gate is now closed. And the rules are, with electrical currents, is once that gate is closed, it's got like a 3-second rule. It's not going to open. And therefore the signal can't travel back up. It's only got to travel down. This gate closes and now this gate opens. So now these positive ones are moving down, more negative ones coming in, and you've got this constant change of negative and positive happening all the way down. You don't need to know the exact science in this. It is quite confusing and it can take a while to kind of get your head around it. But basically, if I draw this axon again, you've got a gate opening, positives coming in. You you have got positives coming out as well, but everything's trying to create balance. And now, this gate closes because the signal's coming down. This gate opens, this gate. So you've just got this constant effect all the way down, which is why when I was saying about these myelinated sheaths, what is myelin sheath? Insulation. It's those sausages. Instead of going in, out, it just goes bam, 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 down to the next one, down to the next one. Instead of having tiny little electrical currents and having all these charges changing all the way down, it just skips it to the next gap, to the next gap, to the next gap. So when some emergency is happening, you move your body quick. Whereas sometimes you don't need to move that quickly. But that's how it changes. So an action potential happens at a certain rate of 70. And therefore, that's why I'm saying all of you have the same pain threshold. You all have the same threshold of movement, but you just tolerate it differently. Our tolerance is different. You don't usually need to know how you have this electrical charge and the way that action potentials work. You'll need to know the term action potential. It's an electrical signal that travels from one neuron to the next until they reach the target audience. Action potentials are what creates this flow of energy from one to the next. So if I go back to this slide here, and we look back at these terms, so the dendrites, they extend from the cell body and receive impulses from other neurons. Are you happy with what the dendrites are? The listeners? Cool. The nucleus, same as any other cell. The nucleus of a neuron is an oval-shaped membrane-covered structure found within the body of the neuron. It contains DNA, the nucleolus, and chromosomes, necessary for the coded production of proteins within the cell. Just like any general nucleus in any cell. So we've got the dendrites, the nucleus within the cell body, and the cell body here, unlike other cells, the neuron cell body, which contains a nucleus, does not divide and multiply. If the cell body becomes damaged, it can lead to the deterioration of the neuron. So what is the process of cell reproduction of two identical cells? Mitosis. Sadly, mitosis doesn't happen. So Alzheimer's, for example, we have degeneration of several neurons, and therefore a lack of neurons and a lack of synapses creates this poor memory link. And there's a lot of study that's going into that at the moment. But sadly, mitosis does not happen like with regular cells. So we've then got, so that's the cell body, the dendrite, the nucleus, the axon, as we've already explained. This extends from the cell body. A nerve fibre that is the longest process in the neuron. So this is the tail, basically. This is where the information travels down. The myelin sheath is formed from support cells and layers of white fatty matter which insulate and protect the axon. It increases the speed of nerve impulse transmission. So these are like the sausage-looking fatty things around the outside of the tail that quickens up the process and speed of that electrical current. Nodes of Ranvier. At regular intervals, there are gaps in the myelin sheath, which are called nodes of Ranvier. These help the conduction of nerve impulses. So this is just the gaps in between the sausage fat. Finally, the synaptic knob. The synaptic knob contains neurotransmitters, vesicles or sacs of chemicals, which send impulses from one neuron to the other. And that's what I'm going to talk about now. Are you happy with labelling this image? If you had to label this, you'd be able to label and you know what a dendrite is, you'd know where the nucleus is and the cell body, the axon, the myelin sheaths, and the synaptic bulbs. So we'll have a go labelling that in a minute. Otherwise, the synaptic knob, I'm going to move on to how this happens. Before I do, I'm just going to show you how there are other shaped neurons. So the one that we're looking at, as you can see here, like multipolar neuron, bipolar, obviously two, pseudo-unipolar and unipolar neuron. It's not compulsory that you learn these. I just think it's quite interesting to think, oh my god, there's just so much going on. If I was to show you this, what would A be? Dendrites. B? Nucleus, which is within the cell body. And C, the long tail axon. What's it covered in? What's that term? Myelin sheath. Yeah. What's the function of a myelin sheath? Insulate to electrical current. Yeah. The pace at which that message is travelling. Nice. So we do have electrical currents, as I've just explained. You have that depolarization, the change of positive and negative, and it's just how any electrical current works. It travels down. That's electrical. These work the same as the immediate cortex. These are like, oh my god, guys, something is happening. Everyone needs to know right now. Whereas chemical, slower, more precise, more to the point, and more like, personal text or more like an email is the way a chemical process works. It's like me telling this one muscle, we need to move, let's get going. Whereas an electrical current is like, oh my god, there's been a car accident, panic, every part of your body, you feel it, you feel everywhere, your heart racing, you feel your pupils are dilating, you feel like your breathing changes, everything is changing. Whereas when you move a muscle, I don't necessarily feel my heart going, bam, oh my god, let's move. It's just happened. If I lift my middle finger, like, it's not affecting the rate of my heart, especially. So that's the difference between electrical and chemical. So electrical is quicker and more direct. But chemical has this ability to change from chemical back into electrical, chemical back into electrical. It's much more detailed. And I'm going to show you now how synapses work. Are you still with me? We'll go through synapses and then we'll have a break. And remember, if anything, no more muscles to learn today. So that's a plus. So synapses. In the human brain, there are about 100 billion neurons, and each of those has 1,000 to 10,000 synapses, which is an insane number to even comprehend. But mitosis does not happen, so you need all those neurons. So a synapse is the meeting point between two neurons. You need to know that term. I would like to explain what synapse is. It's the meeting point, it's the joining between two neurons. I'm going to start to explain about neurotransmitters. So, acetylcholine is the neurotransmitter used at the neuromuscular junction. In other words, it's the chemical that motor neurons of the nervous system release in order to activate muscles. So, a neurotransmitter, so say I've got my cell body here with the nucleus. What does it travel down? What's the tail called? The axon. Covered in myelin sheath. What's the space in between called? Loads around the air. Nice. You then come down and you've got this synaptic bulb. I'm going to do a zoom up of this. So imagine this is one synaptic bulb. And then I've got the dendrite. So I've got my listeners. And that's going to go into my next cell body, yeah? So this is the synapse, this space between this synaptic bulb at the end of this neuron and the new cell, the listener of the new cell. Exactly how when Serena you whispered to Maxine, you were, that space, you weren't mouth to mouth saying it, you had a bit of space between you and your whispering. That is the synapse, so it never touches. Something like 1,000th of a centimetre, way more than that, like insane tiny little space. And this is where the information travels across, and this is where these neurotransmitters travel. So can you remember what a vesicle is? If you look in your images, So a vesicle is just a sac, maybe with fluid in it. It's a fluid-filled sac within the cell itself, and it's made up of what material? It's made up of fat, right? It's made up of the same that the cell membrane is made up from. So because when it merges, we said even in this instance, from cell to cell, when that vesicle, whatever it's carrying, touches that cell membrane, it just diffuses with that cell membrane. So whatever it was holding, it can just merge out. And then the receiving cell takes it, and that's exactly how this works. So these vesicles, these are holding neurotransmitters. They're holding pieces of information. To me, these neurotransmitters are like postmen. So they're carrying a signal. And you have different types of neurotransmitters, different types of chemicals within your brain that affect you in different ways. So, for example, if I said to you, what is dopamine?
Feel good.
Yeah, it's your feel good. It's released when you have sex, or you hug a loved one, or it's just that real feel good. Yeah, it's a feel good chemical in your brain. And so I've got a few more here. So serotonin. This is antidepressants help to regulate serotonin levels. So serotonin mainly inhibitory, and it's a role in regulating mood, appetite, circadian rhythm, and sleep. So your heart rate rhythm. So dopamine, and I'm going to explain about this where it says about cocaine in a minute. So influences emotion and attention, makes you feel awesome basically. And then norepinephrine. An undersupply can depress a mood. So this is your fight or flight. This will get you pumped. Increases heart rate, primes muscles. So you've got all of these different neurotransmitters. We also have acetylcholine. So if I go back from here, acetylcholine is the neurotransmitter that causes muscles to contract. So you need to know that term. I write this down because you should know that. Nervous system, and it's needed for muscle contraction, as well as the muscle's currency. ACETYLCHOLINE, acetylcholine, and that's used at the neuromuscular junction. It's between, so that synapse, and that's what's going to make you guys move dash. You were the efferent, you were the motor neurons.
What's a good sentence to write so that I remember?
Acetylcholine is the neurotransmitter used by motor neurons to activate muscles. So this is a chemical, or it's a neurotransmitter that's going to create a movement. So imagine these vesicles, which are just sacs within the cell, within that synapse, they are now travelling towards the next listener, the next gossiper. So imagine someone like whispering over their fence. This is them with the information ready to go and tell the next person over their fence. And they're just about to speak, and this is that point. So as we had that electrical current travelling down the axon, we had, you've got like sodium, potassium, you've got these changes of electrical currents happening. So that's what's needed for muscle contraction. As well as, what was the muscular currency? ATP, adenosine triphosphate. So that's travelling all the way down. When it gets towards the synaptic cleft, which is this part here, this synapse, calcium is needed as well. We have these calcium gated channels. So calcium begins to enter. What calcium does is it has a change where it pushes those vesicles towards the end of that synaptic bulb, working its way to the next. From here, that vesicle is now merging. It's made of the same stuff with the cell membrane. And so now that neurotransmitter is free and is now floating around this synapse. And you have got receptors on the dendrite that are listening, and once it attaches, once your neurotransmitter, so in this case we want a muscle to contract, so we've got acetylcholine. Acetylcholine is just hanging around that synapse, is making its way down. My dendrite of the next cell is ready to take the information. It receives that message from the neurotransmitter, does something about it. That causes a chemical, an electrical reaction where we've got naturally positive and negative in and outside the cell, and this is going to cause that electrical current that I said. This gate will open, positive ions come in, you've got negative ones coming out, positive going in. It's that jump, all the way down to the cell body, all the way down the axon, then it all happens again. That is how you have a muscular contraction at a very brief overview. It's complicated, right? With regards to drugs, for example, so with regards to cocaine, the way that this working is this within the vesicles. Cocaine is generally your body is carrying alongside that vesicles full of dopamine, serotonin, norepinephrine, as we said. So imagine this vesicle is carrying dopamine. So dopamine is within this vesicle. It's gone down the electrical current, it's got through to the synaptic bulb. We need calcium in order to push that vesicle down to the end of that synaptic bulb. It's now merging with the cell membrane. Dopamine is now floating around in this synaptic cleft. It attaches onto the receptors of the next neuron, the dendrite, and that dendrite, that cell has received that information. Think of the neurotransmitters like postmen. So when you get a message on your door, you get someone knocking on your door, postman, he's carrying a message, right? I don't take the whole postman into my house. I receive the letter, the information, and then I let the postman go, and then he can go back to the post office and the cycle starts again. So what happens is, these neurotransmitters, let's say dopamine for example, dopamine is travelling down, the dendrite receives that information, thanks very much, I'll take that. The postman is about to go back to the post office, cocaine comes in and blocks it. So you have these, where the neurotransmitters left, at the synaptic bulb, you have receptors that receive the postman back in, receive those neurotransmitters back in, because you have a finite supply of them. You don't have a limited supply. But what cocaine does is it blocks these neurotransmitters. So the postman cannot get back into the office. And so they're just like loving life. And so in between all of your cells, you've got this, in between the synapses, you've got all these incredible chemicals rushing around your body, like serotonin, like dopamine, like norepinephrine. You're just feeling like a massive buzz, which is why that can wear off. So if you're taking a line of coke and then it wears off, you need to take another line. You want to keep feeling that way. That's how addiction would happen. But you will have a massive come down because the next day you have that limited supply of neurotransmitters and you've depleted all your supplies. And then you feel like crap until your body eventually starts to create them and make them again. So it's a very slow process. And eventually your receptors will become immune and you eventually rely on cocaine. That's how you would become an addict. So all these processes are involved. It makes you think, like I had no idea when I was researching this, like years ago, how drugs will go to that level. You just think, I'm just taking something and it's, whatever, but how does it have an effect at this level? Like there's so much science behind it and you think, my God.
Explains addiction, doesn't it?
Yeah.
Like some people can't get their heads around addiction, but that really explains addiction.
Yeah, that it's like cellular level, and there is science behind it. So that's basically how the synapse works. But within these vesicles, it's acetylcholine that is used for muscle contraction. So you've got acetylcholine, sodium, potassium, calcium, ATP. All these things are needed for muscle contraction. If I gave you this question in your exam, which compounds are needed for muscle contraction to take place, what would you say? You're going C. What are you going, Serena? You go D. What would you go, Linda?
Oh, you
Probably
see
all of
that,
them,
all of the above.
Charlie?
Yeah, I reckon all of the above now, I've seen that.
Yeah.
All of the above.
Acetylcholine, ADP, adenosine triphosphate, ATP, and glycogen, which is your energy source, which provides you with the ATP. So that is a possible question in your exam. Yeah.
Can I just ask a quick question? The adenosine triphosphate, I've written to remember it. Can you just give me a brief what to write?
It's the body's energy currency. And again, you have a finite supply of that. You don't have a never-ending supply, which is why that's your immediate source of energy. So when you sprint, if you run a 100-metre race, you can use ATP. That'll get you through the 100 metres, but you can't run
No.
800 metres at that pace. Your other energy systems will kick in, like your anaerobic and aerobic systems.
So when you like when they say exercise
Ironing.
obviously lifts your mood and improves like
Yeah.
your well-being,
You
that's
have
because
got
more those chemicals, like
Yeah.
the
Being flushed around your
being
system.
flushed around your system, so you
Yeah.
feel them.
Yeah, not really.
Yeah.
Okay.
And they're not just like hanging around, you increase your supply.
That, yeah, so it actually increases
I
the
don't mind.
supply, which
Yeah.
is why you feel the benefit. That makes sense.
I wonder how you feel if you did like a full-on fitness club and then did a line of coke. You've got even more run around your system, then you're like, hold them there!
Should we have a heart attack, I think?
Oh, God.
I'm going to get that book. I'm actually going to order it in a minute.
Guys, I'm just going to take 5 more minutes and then we'll have a break. So the overview of your nervous system, we have what? Central nervous system, and that contains what? What do you think your central nervous system contains? It's made up of your brain
Oh, okay.
and
Overall.
your spinal cord.
Yeah.
And then you have your peripheral. What do you think that's made up of? So that's your outside.
So like sensory.
Yes. Sensory was what? Afferent or efferent?
Afferent.
Afferent, yeah. So, from motor, you have 2 types. So sensory, afferent, motor, efferent. That divides into somatic. Soma means what? Any idea what soma means? The Latin root of soma means to move. So you might see like somatic yoga or somatic movement classes. That's just what that means. Somatic and then autonomic. Your autonomic divides into sympathetic and parasympathetic. What one out of sympathetic and parasympathetic is your fight or flight? Your stress response. Your stress response is your sympathetic. You would like to think, being really sympathetic, it's okay, it's not. It's not sympathising to you, it's sympathetic to your surrounding and to what's going on around you. So if you are being chased, it's being sympathetic to that, and it's going to help you out in that immediate moment. It's going to make your heart rate pump faster. It's going to make your muscles move quicker. It's going to make your contractions faster. So that's why you have electrical currents. You have electrical signals of contracting. We wouldn't be doing a nice slow email if you're like, I need to know right now. It's like, get everyone involved. Everything's happening. Immediate WhatsApp group text. Let everyone know. So your sympathetic division is sympathetic to your surrounding. It's gonna activate your fight or flight. Parasympathetic is gonna activate the opposite, your rest and digest.
Is that why when some people have like a real imbalance in their body, their fight or flight can be just constant? So they're in like constant stress kind of.
Yeah, if you are
Cause
constantly
that,
stressed, you will constantly be in your sympathetic
That's why
nervous.
it's so tiring, isn't it?
So tiring. But your parasympathetic is also known as your rest and digest. But I've also heard recently feed and breed, which I quite like. Because when you're in your sympathetic system, you're stressed, all your non-vital organs will switch off. So therefore, hunger, for example, if you're physically being, like chased in the wild, you don't need to eat. You just need to stay alive and stay safe. So yeah. So when you're nervous, you don't feel hungry because your body's not doing that. When you're, that's exactly why you'll have like a dry mouth.
Yeah.
Because you'll just be like, you don't need to eat. Saliva is not needed. It's why your pupils will open so that you can let in more light. You can bring in more information to make a decision about it. Your heart rate will pump faster. Your bronchi, your trachea will dilate, so you get more air into your system. So all this is happening. And your parasympathetic nervous system is when you're fully resting, your breathing slows, you wanna eat, you're comfortable, you're slow, all your reproductive systems work. So there's a lot of women working in really high profile jobs that are struggling to get pregnant and their periods will stop. But it's because they're just stressed all the time. They're not letting their body work as it should. And you see these, my mate is having IVF at the moment, so she's been trying for a baby for 6 years. And we were at a festival for her at the weekend, over the summer, so this is when she was prepping for IVF. And was like, obviously we were having a great time. I'm not trying for a baby, so I was obviously like dancing and having a great time, so having several beers. And so was my mate, and I was thinking, it's not my place to say, but I was like, if you are that desperate, you need to be helping your body. You should be resting. You should be calming at home, have a break, chill out, let your body fully rest. Because if you're working all the time and your relaxing time is, I'm going to go for a sprint, I'm going to go to a hit class, I'm going to go and party hard with my mates, that's not resting your body. It might be a switch off for your mind, but your body is just keeping up. Have you guys ever been on holiday and then got sick?
Yeah, the minute you stop on
Yeah.
holiday, you get
That body's definitely like,
Definitely.
Yeah.
body's like,
and the parasympathetic, so when you're in deep rest and deep sleep, is when your immune system is performing best. So if you're constantly stressed, your immune system isn't working to its limit, and that's why you can constantly get sick. And if you don't rest in that sick period, and you're like, I'm just going to keep going through, then you hear all these people. Like I hear it here at the college, and people are like, oh, I can't have a sick day, and then I'm like, well, you're not getting better. It's been like 5 weeks now, and you're still not well. Like,
that's
And if you
why.
don't sleep, it's terrible because all those things, nothing's like repairing itself. Like I don't sleep, haven't slept for years, and Phil thinks it's amazing, as in I can carry on all day and night. But I'm like, yes, but you don't realise what it's doing to my body. You know, I may be someone that can carry on somehow, which I do. I could carry on all day and night, but I say to him, it's really bad long term.
yeah.
You know.
Yeah, definitely. And there's a really good podcast. Have you heard of Deliciously Ella?
Yeah.
She's got a podcast, and there's a sleep expert on there. And my God, I have changed like a lot of my routines because, well, not this morning. Like, so I was at the gym this morning before work, but sometimes if I'm not feeling like on top form, normally I'd like just get up and deal with it, and I'll be fine after. But now I'm starting to think, like, obviously up at 6, I could have got up at 7, and that hour and a half, you don't realise how important that can be. So if you're not feeling your best and you feel like physically really run down, then can you weigh it up and can you see maybe I need that sleep more than I need the exercise? I'll do that later on somehow, because yes, it can make you feel good instantly, but your body might be recovering. So but if you can listen to that, it's a really interesting one. Can't think what his name is, but it's on the podcast. Cool. Okay, and then we're going to be looking at the brain. So should we go for a break?
How does that like work in terms of like dementia?
With the neurons. Yeah. So yeah, Alzheimer's is a form of dementia.
Just thinking, I'm more wondering, because my mum doesn't have it, but my mum had a mini stroke, and said because of that, she needs to be very careful. She could
I'm great.
from
I
that.
can't
Yeah. There's loads of research that's being done about how you can build the synapses. So say you only have 5 synapses,
Yeah.
and you have like one piece of information for the next piece of information.
Yeah.
That's going to be hard to store that in your short-term memory. Whereas if you just say like, I've got 5 things to remember, 5 names, Cash, Ada, Rita. When I'm learning your name for the course, if I only remembered your names, it would be hard. So at the beginning, we go round, we do like 3 facts. It's because I'm building and getting all this information, and my synapses will remember all different types of information.
Yeah.
And that's how your memory is getting good. So when you're learning something, if you stop learning,
Yeah.
your synapses will just lose that ability to retain information and find information and search for it. So
Feels like to me all the
the
time.
mind is like a muscle. You need to keep.
work.
Yeah.
I mean, she does. She still works and everything, but I think she's just really aware of it. Which is good that she's aware of it, but like she worries about it, and then I'm like, that's causing you stress.
Yeah.
Like you have to just do
So
exercise.
if she's working, that's enough.
Yeah. Exactly. Oh, I need a coffee cup, don't I? Forgot the cup. Yeah, I just nearly did that as well.
I with it today. I knew I wasn't. Good. I looked at myself in the mirror. I can see because I had an accident on a horse years ago. If you look at me closely, I've actually got a lump there. Can you see under my eye? If I've cried, I get like a full-on bright red circle that takes hours to go away. Because I hit my face, my cheekbone. So when I'm tired, it really stands out.